Reverse engineering the AC line filter EMI filter of online UPS and enhance the AC line filter EMI filter. What is reverse engineering? How does it work? Reverse engineering is also known as backwards engineering or back engineering. Reverse engineering is a process or method through which one attempts to understand an object to see how it works, how previously made the device, and the process and its system. Reverse engineering is done primarily to analyze and gain knowledge about the way something works, but often it is used to repair and enhance the object. Noises in AC line. Electromagnetic interference (EMI) is defined as unwanted electrical signals. The EMI can be in the form of conducted or radiated emissions. The conducted EMI is where the noise travels along the electrical conductors. The radiated EMI is where the noise travels through the air as magnetic fields or radio waves. AC line filter, EMI filter. The function of EMI filter is to reduce high-frequency electric noise that may cause interference with other devices. Regulatory standards exist in most countries that limits the amount of noise that can be emitted. Most of industrial electronics device contains an EMI filter, either as a separate device or embedded in circuit boards. In our previous video tutorial, we have done the reverse engineering of this AC line filter or EMI filter of our online UPS system. Here this one is line, this one is neutral, then two varistor, then X capacitor, then this one is X capacitor, this yellow one is X capacitor, then this choke, this one is common mode choke, then these two is Y capacitor, and then line and neutral. The parameters for Y capacitor are given here. The parameter of X capacitor, this X capacitor is shown here. Study the AC line filter EMI filter. This one is AC line filter or EMI filter. Line neutral, then two varistor, X capacitor, value is given here, then differential mode choke. There is two differential mode choke, then common mode choke, then Y capacitor with chassis, and this is our filter output. First we will discuss about varistor. These are varistor. Metal oxide varistor move. A varistor or voltage dependent resistor VDR is used to protect a circuit or electrical device from high transient voltages, high voltage surge, spike protector. Varistor are planted in the devices in such a manner that it will short itself when a high current is produced due to high voltage. What is an AC line filter? AC line filters are used to suppress a conducted electromagnetic interference EMI. AC line filters consist of chokes or coils and XY safety capacitor for proper current return. X capacitor, this one is X capacitor, Y capacitor, this one is Y capacitor with device body or chassis, X capacitor, then Y capacitor, common mode coil, differential mode coil. Use of AC line filter, electromagnetic interference filter. AC line filters are used in all electronic circuits and devices that plug into the wall and operated by using the use of AC power. This can be a home appliance, lighting equipment, TVs, computers, laptops, battery charger, power supplies, as well as a number of other things. What type of noise needs to filter out? There are two different types of conducted electromagnetic interference. The first is differential mode DM electromagnetic interference, and the second one is common mode CM electromagnetic interference. The differential mode DM, which is sometimes called normal mode, it is conducted on the signal line and the ground line, and it goes in opposite directions to one another. Common mode CM, the common mode CM noise is conducted on all lines in the same directions. So the right types of chokes must be chosen to attenuate the right types of noise. What makes the differential mode choke different from common mode choke? Differential mode choke consists of one coil which is placed in series with one of the AC line. This is choke for differential mode. It has two terminal, two pin, one coil, two pin, and in our system you have to connect two choke, one in line, another in neutral. Two choke, one in line, another in neutral. For first choke, one side is line, another part is output line prime. One side is neutral, another side is output neutral prime. The common mode choke consists of two separate coils with a certain core material. That means here is two coils but same core material, and consists of four terminal. It has four terminal, 1, 2, 3, 4. Four terminal. It has and consists of four terminals on each side, and that are connected across both AC lines, line neutral. For this coil, one is here line, another is here line prime. For this coil, one is neutral, another is neutral prime. This one is input, this one is output side. Common mode choke. A common mode choke is an electrical filter that blocks high frequency noises which are common to or more data or power line. Actually, this coil filter out those high frequency noises which are common in both lines. Common mode noise current is typically radiated from sources such as unwanted radio signals, unshielded electronics, inverters, and motors. Unfiltered, this noise present interference problem in electronics and electrical circuits. How current of differential mode noise attenuated or filter out? This one is main application. When current of differential mode noise flows through a single coil of a differential mode choke, magnetic flux occurs, and the coil magnetic flux create impedance, and that electromagnetic noise is attenuated by that impedance. That means when differential mode noise flows in this path, then magnetic flux occur here, and this magnetic flux create an impedance, and due to this impedance, differential mode noise attenuated or filter out. Differential mode choke, current flows, normal current flows to the coil, then normal current flows to the coil, then magnetic flux occur in the coil. The magnetic flux creates an impedance and the electromagnetic noise is attenuated by the impedance. Application for DM. Application for DM continue. For differential mode current, the return path has to be through an X capacitor. When it makes impedance attenuate the signal, then there must be a return path. It has to be through line to line or line to neutral or line to line. For three-phase system, it may be line to line or line to neutral, but for single-phase system, it must be line to neutral. When differential noise current flows through the coil of common mode choke, the magnetic flux is cancelled by each coil, and then impedance is not active. So, for differential mode noise current, here impedance cancelled each other, so there is no action here. How current from common mode noise attenuated or filter out. How current from common mode noise attenuated or filter out. When current from common mode noise flows through the both coil of a common mode choke, the magnetic flux occurs in the same direction and increase the impedance, and the electromagnetic noise is attenuated by that impedance. Common mode choke, common current flows through the coil, then magnetic flux occur in the same direction, increase the impedance, and common mode noise current or common mode signal attenuated or filter out. For common mode current, the return path has to be through Y capacitor. For common mode current, there must be a return path, and these are return path. These are called Y capacitor. This one and this one Y capacitor. There must be Y capacitor, and Y capacitor must line to chassis or body, and neutral to chassis and body. There must be two capacitor. For common mode choke, now we will study effect of two types of signal or two types of noise: common mode noise and differential mode noise. This one is common mode coil or common mode choke. This signal, they are in same shape. When they pass through the common mode choke or common mode coil, then they cancel each other. So in output there is no noise. But when differential mode noise apply in common mode choke, then signal are in same shape. That means common mode choke cannot filter out your differential mode noise. This one is common mode choke. This one is differential signal noise. Then there is no action. This is common mode choke, and this one is common mode signal noise, and signal noise are attenuated. Now this one is the conclusion part of our reverse engineering process. Here we proposed enhanced AC line filter for online UPS, existing design without DM filter. That means in existing system their DM filter is not present. We suggest there must be a DM filter. We suggest there must be a DM filter. And then another suggestion is there's two varistor. When high voltage spike comes, this varistor becomes short. So to protect our device or electronic circuit, we suggest we have to use on safety fuse here. Fuse is very easy to replace.